This is Dr.D Govardhan, Professor in the Department of Aeronautical Engineering, Institute of Aeronautical Engineering in Hyderabad. Today we are covering resultant of system of forces and related problems. When several forces are acting on it, all the forces are replaced by single force which will have the same effect on the body. The single force is treated as a resultant of all the forces. The resultant of all the forces can be determined by using two methods, graphical method and method of resolutions. In a graphical method, we can determine by using parallelogram of forces, triangle of forces. These two are applicable when the two forces are acting simultaneously at a given point on a body. That is, they are concurrent forces. The law of Polygon forces, it is useful to determine the magnitude and direction of the resultant force when the several forces are acting on it by using law of Polygon forces. In this procedure, all the forces are represented as sides of a polygon taken in order. The closing side is representing resultant of all the forces but in opposite order. But this method, it requires more concentration because all the forces are represented both in magnitude means by selecting some suitable scale. The second one is the method of resolutions. In this method, the forces are resolved into two rectangular components, preferably along the x direction, y direction, horizontal and vertical. The algebraic sum of all the forces in x direction is treated as a component of resultant force in that direction. Similarly, the algebraic sum of all the vertical forces is treated as a vertical component of the resultant force. Then by using the relations R is equal to the resultant magnitude of resultant force is equal to under root of x square plus y square. Similarly, the direction is given by theta equal to tan inverse of sigma fy divided by sigma fx. Today we are solving the problems by using method of resolutions. Now a system of forces are acting on the corners of a rectangular block as shown in figure 4. Determine the magnitude and direction of the resultant force. Resolve the forces horizontally, which is represented here as sigma h. It is equal to 25 newtons toward the right side. The forces which are acting toward the right side are generally treated as positive, and 20 kilonewtons which is acting toward the left side, they are treated as a negative now. Hence, the algebraic sum is equal to 25 minus 20, which is equal to 5 kilonewtons. This is treated as the component of resultant force of these four forces which are acting on the corners of a rectangular block. Similarly, sigma v is representing some of the components of vertical components. This is treated as a vertical component of resultant force, which is equal to 50 kilonewtons. It is acting downward directions, hence it is a negative, and 35 kilonewtons also it is acting in downward directions, it is also negative. Hence, the total sum now becomes minus 50 minus 35, which is equal to 85 kilonewtons. The magnitude of the resultant force is given by under root of sigma h whole square plus sigma v whole square. On simplification, we got 85.15 kilonewtons. This is representing only the magnitude. Let theta be the angle which the resultant force makes with the horizontal. Then tan theta is equal to sigma v divided by sigma h, which is equal to minus of 18 divided by 5, or theta is equal to 86.6 degrees. Here, Sigma h is positive. That is, if you take the coordinates like this, x is a positive and y is a negative. Hence, this it is belongs to fourth quadrant. Hence, here theta what we have got just 86.6 degrees. It is the angle made by the resultant with the horizontal. Hence, the component of forces, as per the component of forces, the resultant force is making it in the fourth quadrant. Hence, theta is given by 360 minus 86.6 degrees, which is equal to 273.4 degrees, which is obtained when measuring this inclination with respect to the x-axis in a counterclockwise directions. Similarly, the second figure is given. Three forces of 20 newtons, 30 newtons, 40 newtons, and 50 newtons. The four forces and 60 newtons are acting at one of the angular points of a regular pentagon toward the other five angular points taken in order. Find the magnitude and direction of the resultant force of a given force as shown in figure. Okay, resolving all the forces horizontally. Here, the component of forces which is acting in the direction of AB, since it is horizontal, it is not at all having any vertical component. Hence, these forces are treated as Fx1, that is the x component of first force, F1x. It is equal to F1x is equal to 20 newtons. Similarly, the force which is passing through point AC, which is making an angle of 30 degrees here now, since it is a rectangular pentagon, and the forces are acting from A to the corners of the pentagon now, as shown in figure, away from it now. So, the force AC, this is treated as here F2, which is equal to 30 newtons now. When it is resolved into two components, the x component is moving toward the right side and y component is in upward direction. So, the x component is given by 30 into cos 30 and y component is given by 30 into sin 30 and so on. Similarly, take sum of the horizontal component of all the forces now. One is 20 cos 0, since 0 is inclination, 30 cos 30 plus 40 cos 60 plus 50 cos 90 plus 60 cos 120, and putting the values of cos 0, cos 30, cos 60, cos 90 and 120, we got 36.0. This is the sum of the components of all the forces in horizontal directions. Similarly, the sum of the vertical components is equal to sigma v is equal to 20 sin 0 plus 30 sin 30 plus 40 sin 60 plus 50 sin 90 plus 60 120 degrees and so on. We got 151.6 newtons. The magnitude of the resultant force is given by R is equal to under root of sigma h whole square plus sigma v whole square, which is equal to under root of 36.0 whole square plus 151.06 whole square. We got 155.8 newtons. This is our magnitude of the resultant force. The direction is given by, since it is a vector quantity, the force, when we are representing it required both magnitude and directions. The direction is given by theta is equal to tan inverse of sigma v divided by sigma h naught. So, on substituting the values, theta is equal to tan inverse of 151.6 divided by 36.0, we got 86.6 degrees and so on. Since both the values of sigma h and sigma v are positive, therefore the actual of the resultant force lies between 0 to 90 degrees now. Taking just one more problem. The following forces act at a point 20 newtons inclined at 30 degrees toward the northeast. Assume this force is not treated as F1. 25 newtons toward the north, F2. 30 newtons toward the northwest, F3. and 35 newtons inclined at 40 degrees toward the southwest. F4 is given. Find the magnitude and direction of the resultant force. Here on resolving the force F1, it is equal to 20 newtons into x component, y component. It is thus x component is acting toward the right side, positive. Y component is acting upward direction. It is a positive. The second force Ft is the vertical now. Hence, the x component is 0. It is having only y component, which is equal to 25 newtons. F3, again when it is resolved in two components, one in the x direction and y direction now. The x direction is moving toward the left side, hence it is treated as negative, and y acting upward direction is positive. Hence, here the x component is given minus of 30 into cos 45. Y component is equal to 30 into sin 45 degrees and so on. For F4 force 35 newtons, on resolving the force into two components we got x is again toward the left side and y is the downward directions. These two components are here treated as negative value. Now, sigma h is equal to 20 cos 30 plus 25 cos 90 plus 30 cos 135 plus cos 20 220 degrees and so on. Everyone, just we are measuring that inclination with respect to the counterclockwise direction x-axis. On simplification, we got sigma h is equal to 30.7 now. Similarly, sigma v is equal to 20 sin 30 plus 25 sin 90 plus 30 sin 135 plus 35 220 degrees. On simplification, we got 33.7 newtons. The magnitude of the resultant force is equal to, we got under root of sigma h whole square plus sigma v whole square, which is equal to under root of minus 30.7 whole square plus 33.7 whole square, which is equal to 45.6 newtons. So theta be the angle which the resultant force makes with the east, that is the x-axis now. Tan theta is equal to sigma v divided by sigma h, which is equal to 33.7 divided by minus of 30.7, which is equal to minus of 1.098, which is equal to 47.7 degrees. Okay, in this calculations we got sigma h is a negative. That is again if you draw the y coordinate, h is a negative and y is a positive. That means it belongs to second quadrant. Hence, the actual resultant force is given by 180 minus of 47.7, which is equal to 132.3 degrees.
Like, share and subscribe. Hit the bell icon for more updates.